Okay, so let's continue. I think that one got a little boring, so let me start it again with simpler examples. So, log is nothing but just a way of writing and asking you that in the first equation, for example, 10 to the power what is 100? So, 10 to the power 1 is 1, 10 to the power 2 is 100, 10 to the power 3 is 1000, 10 to the power 4 is 10,000, and so on. So, the answer is 2 for the first one. Or let's look at the other. Log of 100 to the base 10 plus log of 100 to the base 10. So we just did that, it is 2 plus 2. Can we write it in the same way in a bracket in the question mark something that would mean the same? So I think yes, we can do that. So this would be like 100 and 200, because ultimately we are looking for an answer of 4. So if we have something in the multiplication, we can write it because we are playing with the powers. 10 to the power what is 1000? So 10 to the power 3 is 1000. uh, 10 to the power what is 100 into 100? So again 10 to the power uh, 4 is 100 into 100. Oh. Then we have 10 to the power 2 into 10 to the power 2. It's nothing but 10 into 10 4 times. So we are just checking out one formula that we had in the book, which says that log xy to the base a is log x to the base a and log y to the base a. So it's nothing but just writing the things here and there. Again, a simple question for you. Log uh, 10 log 10 to the power 5 and the base is 10. So you're asking me 10 to the power what is 10 to the power 5? So 10 to the power 5 is 10 to the power 5. So this is like quite a straightforward thing. So 10 to the power 5 is 5. So can we not write this into log 5 uh, log 5 times log 10 base 10, because we know that if something is going to be repeated many times, it does not make sense, because we will search for 10 to the power what is 10 to the power 5. So whatever is in the exponential, we can bring it left. You can also search for some other methods. So in other ways, log is nothing but a question, or writing the same way in which you ask 10 to the power 1 by 5 is what? Uh, so what is the number when multiplied in it 5 times give you 10? So 2 multiplied by 5 times is 2 into 2 4 into 2 8 into 2, or it's a big number, so this should be a very small number, 1.7 or something like that. So we can write this as the same equation. If we are searching for like y equal to 10 to the power 5, we are searching for y. If we can write this into the log format, we can say we can take log on both sides. If you don't understand this term, log on both sides, you can think of this as we are writing this equation into log format, and we are going to ask uh, the question to us in the same way. So log, if we take log on both sides, we can solve this, because we'll have 1 by 5 into log to the power 10. We are just playing around with the rules of exponential to get to the answer. If you don't understand the last few lines, just ignore that. Let me come back to the question that I was solving. uh, Suppose we want to find out when the population which is growing up at a particular speed would double. So suppose the population growth is 10 to the power y. So at 1 year it's 10, at other year it's 100, at the third year it becomes 1000, at the fourth year it becomes 10,000, at 5 year it becomes 100,000, at 6 year it becomes a million, at the seventh year it becomes 10 million, and so on. Suppose that's the growth rate, and we want to find out when that would double. So if that's happening, we have just written down the equation where we start with 100, and the equation of the population is 100 into 10 to the power y, and we would search this. So till the time when we get to this equation where we'll get 2 equal to 10 to the power of y, we are asking us in a way that 10 to the power what should give us 2. Then we can take a log of both sides, because taking the same doing the same thing on either side of an equal to sign will not change the thing, whether it's division, multiplication or log. And then we can bring y out, because we just studied that whatever is on the top we can bring it out and multiply that, and we can search the value of y. I can put this into a very simple equation maybe and show you the same thing. So I'm asking to you, in how many years, so now I have changed the equation. The equation follows is, in the first year the population is 10 to the power y, which is 10 to the power 1, and you keep changing that, and you want to search when it would. So here it's like 3, that you can just plug in the number and see. So if that is the case, let's try to do that. Then we'll have 100,000 equal to 10 to the power 5, 10 to the power y. Suppose we want to take a log, so we take a log of both sides, so this become a log of 1000. Now we know that log of 1000 is 3, and y into log of 10. So 10 to the power of what is 10? It's 1. So this would become 3 equal to y into 1, which is 3. So 3 years. So we have solved the same very simple equation which we could observe by our eyes, that 10 to the power what is 1000, 10 to the power 3 is 1000. So we have solved the same equation in using the log thing, by taking log on both sides. So log will help us to search for something in power when we want to use the calculator. So earlier, when we did not have the calculator, we had those charts where you will have values of log 3, log 4, log 5, so that when you get in the exam you can look the log table and search for the answer, because otherwise it was difficult. So exponential is something that grows very fast. It could be on the upside, growing very fast on the up, or it would be decaying very fast or going very fast towards 0.